Hello and welcome to today's webinar. My name is Tara Houston, Member Program Supervisor for the Advanced Textiles Association. Our webinar today has been created and paid for by Viaflex and is titled Castle Rock Reservoir Utilizing Reinforced LLDPE, presented by Alex Nichols, Senior Account Executive, and Pat Elliott, Director of Installation, both from Colorado Lining International, a Viaflex company. The Advanced Textile Association is providing this webinar platform for companies to feature their content, products, and services through our sponsored webinar program. ATA has not vetted the content and does not endorse or recommend any of the presentation. The opinions and content are exclusively those of the presenter. Before we get started, here are a few housekeeping notes. During today's webinar, you will have the opportunity to submit questions or comments by typing them into the questions box of the control panel. You may send in your questions at any time during the presentation and we will address them at the end. Today's webinar will be recorded and sent out in an email tomorrow coming from GoToWebinar. I will now pass things off to today's speakers, Alex Nichols and Pat Elliott.
Good afternoon, everybody. I'm Alex Nichols, Colorado Lining International Viaflex, Pat Elliott, Director of Installation Services. Quick overview here. I've been in the geosynthetics industry for about 18 years, from fabrication to installation to estimating to sales now. So we're just going to do a quick overview of Viaflex as a whole. We're based out of Sioux Falls, South Dakota on the manufacturing side. We have 15 lines, manufacture a number of different products, ranging from 2 mil up to 80 mil, pretty much anything you can think of as far as geosynthetics go. On the install side, like I said, we're based out of Parker, Colorado. So like I said, Viaflex is manufacturing out of Sioux Falls, South Dakota, formerly Raven Industries. Raven acquired Colorado Lining back in 2017. Colorado Lining was a fabricator and an installer of geosynthetics, geomembranes. Raven acquired us, and then basically then became another, basically a private equity firm after that, becoming Viaflex. We manufacture out of Sioux Falls, fabricate out of Madison, South Dakota, Midland, Texas, and then we install out of Parker. Colorado Lining's been around since 1978, doing installations all over the world.
All right. Thanks, Alex. All right, I'm going to take it from here. Today's presentation is on the Castle Rock Reservoir project. A little bit of history on this project. Castle Rock is a town located about 20 miles south of Denver, right up against the mountains, as you can see out here in the distance. The actual site is in a little town called Elliott, and it sits about 5 miles to the west of the town of Castle Rock. The original construction of this reservoir was built by a water district that builds and develops water infrastructure projects all around Colorado. As a matter of fact, we've done several projects for them. And in this case, once they built the reservoir, they actually sold it to the town of Castle Rock to meet their needs. What you can see here, this is an aerial photo, and you can see the construction of the larger reservoir here that I'll get into later. So once the town of Castle Rock procured the original pond that you can see off here, Reservoir 1 as I'll refer to, they put this into their water system and use it as a raw water storage. Once that was built and in service, the town of Castle Rock operated this for 5 to 8 years approximately. I don't know the exact dates on when they purchased it, but they used this. And then around 2020, they started to notice some failures, and they actually reached out to Colorado Lining, and we went out and visited the site numerous times over those few years looking at this. And then they actually brought in W.W. Wheeler as the consulting engineer and the engineer of record to design. we spent, oh, here, let me advance slide here. So this is the original reservoir number 1. And when it was constructed, the construction design was actually a woven geotextile with a spray-on polyurea. And as you can see here, that began to fail. And in those numerous visits I was talking about around 2020, we started to see all this failure, and we could just see a little bit of the exposed geotextile. And what you're seeing here, and the reason I picked this photo is because it's a little more up close, but these streaks that you're seeing is because this was a spray applied membrane. And what happens is, if you can see my hand, it depends on the thickness on how quickly the operator that is spraying the polyurea. If he goes fast, it's a thinner layer. If he goes slow, it's a thicker layer. And so what you're seeing here is, you know, as the sprayer works his way up the slope, you can see there's overlap. So these lines going up is from where he did one pass and then came and then covered that other pass. So these lines are, the polyurea is twice as thick in those areas, and you can see that it didn't fail. So it began to fail in the thin areas faster. So in around 2020, when we made our first site visit, they asked us to look at options to repair this. Well, obviously we do traditional membranes. We do, you know, LLDPEs, polypropylene, CSPs, HDPs, membranes like that. Well, we cannot, and we weld all of our membranes. So you can imagine that we didn't really have a good solution to fix this. We talked about, you know, lining the slopes and trying to secure it around the perimeter, but just no real good solutions came out of those meetings over a few years. And even when they were, you know, this is your typical water level, so you can see the dramatic difference in how it was failing above water level versus below. But what they did notice is that even when they were operating below where the major UV failure was happening, they were still getting a tremendous amount of water loss. So they, you know, there was really no good solution. So we talked about, you know, putting in a lightweight, thin material over the entire reservoir, but it really in the end that they decided that, you know, they're just throwing good money at bad at that point to try and repair an already failing reservoir. So some of the design challenges that we came up with, the town required increased water storage over the original reservoir that they had. Douglas County, Castle Rock is the county seat for Douglas County, which is one of the fastest growing counties in the nation for, you know, 20 plus years. I can even remember back when I moved to Douglas County many years ago, it was top 4 for 3 years running back 20 years ago. So just a, you know, ideal place to live. It's outside the city. So a lot of people are moving to Castle Rock or to Douglas County and therefore Castle Rock. The site, since it was already secured, I'll show you the next slide, but the site had a lot of topography. So it was near not a river, but a river bed, a low-lying area that, you know, the seasonal creek that runs by there. And so the topography was kind of difficult, made it a challenge for W.W. Wheeler to you know, make the dirt balance, that kind of stuff. They also needed to keep the reservoir in service during the construction. So the goal is never to come offline. So the ideal situation was large, deep reservoirs to increase water capacity. As you can see here, this is kind of a fun slide. I actually took this out of the seat 11A on a United flight coming back from Phoenix one time. So this is kind of a fun photo. As I'm taking this out the window, I got a nice aerial shot. And this is during the construction of Reservoir 2. You can see the geotextile here and the tan liner going in. So this was during, we were currently active working on Reservoir 2. So again, some of the design challenges. Required a second reservoir, so they wanted a larger reservoir built up. One of the challenges was this is the low-lying area where they needed to, where it was required to build Reservoir 2. So there was a tremendous amount of soil that needed to be built up to get this reservoir, you know, this elevation at this side, at the west side of the reservoir to the east side of the reservoir was pretty dramatic. So they had to build this east side up I don't know, 80 feet. And you can imagine the size of the embankment. So the soil balance was difficult and a challenge. So one thing that we came up with during this process, and we were kind of heavily involved in this with W.W. Wheeler in the town of Castle Rock, is we decided to line the reservoir halfway up. And I'll show you the next detail, but I'll get more into that. So we could put the bottom half of this reservoir in service, so then we could then take this reservoir offline. And I'll show you in the next slide here. So here's a couple of the design details. So what you're looking at here is, this is the construction of original, the bottom half, let's say, of Reservoir 2, what we refer to as phase 1. And the membrane comes up the slope and goes into an anchor trench right here. And then HEI is the general contractor, which are doing an amazing job as well. Shout out to them. They then built this additional berm, getting the width wider, getting the access road around the top. This was the original phase 1 berm. They were able to take this soil, since Reservoir 2 is now online on the bottom half, they were able to take Reservoir 1 offline and use the soil of increasing the size of Reservoir 1 to build this embankment up to get to the more depth, to get to the desired water that they needed, right? So this is kind of a challenge because, one of the big no-nos in the liner industry is you don't want any horizontal seams, right? So what we discussed was, we came up with this design with W.W. Wheeler. And so as they came up and they put this in the anchor trench, this material stayed in place. And then when we came in line, and you'll see in some of the photos throughout, and I'll point it out throughout the presentation, we then came in and lined up here and we put a horizontal seam all the way around here. But we did not use a traditional wedge welder where we would actually cut the membrane. So we actually just came down and overlapped and did a hot air welder. That way we could keep the anchor trench in place and eliminate the stress of that horizontal weld. And then, as you can see in this, I'll get into this detail a little bit later as well. There's a curb detail, and I'll tell you kind of a little bit of the history on why we came up with that detail and did this design here. But we actually put a curb around here after we put the membrane in an anchor trench, and then we actually sealed this curb. But there's a lot more in that later. All right, so one of the neat things about this project is we had another project, and this project is the Chambers Reservoir, and I've actually done some presentations at some of the shows on this reservoir. This reservoir here is in Parker, Colorado, which is our hometown, and we had this was for Arapahoe County, a neighboring county. This reservoir actually sits inside Douglas County, but Arapahoe County owns it and operates it. And we had the unique ability to learn and mimic things they did and learn from lessons learned and some of the challenges that we faced on this project that we completed in around 2019. So you can see here, here's an aerial photo of Chambers Reservoir. And the benefit of having a large-scale reservoir like this in a neighboring town was, it was pretty critical. And I think W.W. Wheeler and the town of Castle Rock would agree that we had this fantastic idea to, like I said, use this. So Kevin over at Aqua, he was super gracious, amazing guy. He let us come out and tour it several times, told us everything he loved and hated about the job, loved and hated about Colorado lining, and how the job that we did, and the work that we had done for him, and it was just a very good opportunity for lessons learned. And both of these projects are a little near and dear to my heart. Probably Alex is a little bit too, because he grew up in this town. But you can see off here in the distance, it's small, but that's my kid's high school. So during the construction of this reservoir, I get a text from my 17-year-old son going, "Hey, your crew's working out there," telling me who was working and who wasn't. So that was kind of fun. And then also, my mom lives in Castle Rock, so it's kind of fun that these projects are close to our home. So some of the lessons we learned: tan material for water temperature and aesthetics. Castle Rock mimicked that as well. The town of Castle Rock liked the look of Chambers Reservoir, liked that tan look, and liked that reduced heat. You'll see in the next photo too, but that perimeter curb kind of came from the challenges that they were having at Chambers, the way the road was constructed around the perimeter, and I'll get a lot more into that. Safety ladders for egress and ingress. We loved these. We were able to walk up and down them. The town of Castle Rock, W.W. Wheeler was able to walk up and down them during, after this reservoir was in service. So they got a real feel for how they work and why they liked them and, where they would want those to use. They loved the material. We used a reinforced LLDPE for very high strength and good water quality and good dimensional stability. The reinforced material also helps when you're dealing with extremely long, deep, large slopes. When you're building these reservoirs with these long, these slopes are at Chambers are over 160 feet long. The panels were 160, so like 140 feet. We're talking 2 to 1 on 70 feet deep. So these are long, deep slopes, and you worry about slope creep, especially with a material that doesn't have good dimensional stability and also is unreinforced. Ramp, Chambers had a ramp as well as Castle Rock. They like this construction, so they could access the reservoir with a roadway for future, boats. That was one of the things that they require. They put boats on these reservoirs for testing water quality, depth, that kind of thing. They want to be able to access these reservoirs with fairly large boats. Castle Rock wanted a larger boat than we were using at Chambers, but so we learned a lot at Chambers as we built this ramp. Some of that I'll get into later. Venting and ballast, making sure we can prevent wind uplift. So you have good ballast and you have good venting of the membrane around. As you can see here, we used a heavyweight geotextile at Chambers, which we ended up doing similar to that at Castle Rock, and the advantage of a geotextile. So I'll get into some of those later. All right, so I'll talk about these different things. So the tan material, like I said, they like the look of that. They liked the aesthetic look of that at the Chambers Reservoir. They wanted that same look. They liked the idea of the reduced temperatures from the black membrane, and just even the temperature of the black membrane to touch, and just purely for aesthetics. And you can see here some of the details that I'll get into around here. In this photo, I want everybody to make a mental note of, see this rock around here? This was something that was happening at Chambers that we wanted to prevent at Castle Rock. So I'll show you how we did that, and I'll mention that again, but this photo kind of illustrated it. So I just wanted everybody to make a mental note of that. So here's a couple standard details. These are things that we used. Typical anchor trench, depending on the audience here, I don't know, but this is just a standard anchor trench. The mud liner comes up, has a run out of 2 to 3 feet typically, goes down into an anchor trench that secures then when you backfill this secures the perimeter. This is a very common detail. Most 99% of our projects use this detail. And the other one is a mechanical attachment to concrete. We typically use this in attaching to structures, which I'll show you in the future slides here, but we also can use this as a perimeter anchor. We do some large floating cover projects for drinking water reservoirs, and this is a common attachment to replace the anchor trench around the perimeter, where we're actually securing the liner all the way with this mechanical fastening. As you can see here, here's the anchor trench that I was showing you. You can see the run out. This is important that you have this run out to prevent during construction. If you can imagine, if you have that membrane come up and drop right in, this crest here can get knocked down, and you can get not a nice clean edge, and you can lose some of your freeboard during the construction. So it's important that this dirt work is done good and you got a nice wide area right here. This was also critical for the design of this project because we actually use this to attach later, or I'll show you in the next slide here. You can also see this is phase 2 construction. So you can actually see the geotextile being installed. This is a phase 2 panel. This was phase 1. So right here, you're going to see, this happening quite a bit in these photos. Over this is the bridge, but if the bridge wasn't there, you could see the dirt, exposed dirt around here. And as part of phase 1, since we were cutting into a slope, this portion of the reservoir, the southwest side of the reservoir, was already to grade of the final grade. So we actually lined all the way up on a portion of the reservoir and then came up and added that berm around there. One of the things I want to note about this phase 2 construction is doing this seam over the top of water was a little crazy. We actually had to put in several extra safety measures, especially you can imagine this is not a textured membrane, this is a smooth membrane. So you can imagine working on a side slope doing this weld, hot air welds all the way around this perimeter. And we did get some rain events, and we had to make sure that the guys had people up top that could get them out in the event of a rain event, because we don't have the safety ladders installed. So we had to have temporary safety ladders. We had to have guys tied off. We had to make sure that the cords wouldn't allow, if somebody dropped a heat gun or a welder, that cord length wouldn't allow it to go into the water. So we'd had to put in extra precautions. All right, so what you can see here, this is us putting in the perimeter curb. We're actually doing this currently. This picture is only from about a week ago. What you're seeing here on the right is the Chambers Reservoir. And this was kind of a critical detail because you can see this design had it come up and this rock, and you can imagine how much rock is sliding down this. Every rain event, people walking, wildlife, anything that disturbs this rock is sliding down the slope. And this was one of the big frustrations that Aqua had at Chambers, was all this rock getting in there. Obviously, some of this was a little bit out of control, out of our control. I mean, it didn't really have anything to do with the liner or, the general contractor built it, and the engineer didn't realize at the time the effect of that. But it's critical that it was one of their big frustrations. It's probably one of the things that stuck in their mind that they didn't like. And when Kevin was talking to W.W. Wheeler about the Castle Rock project, they kind of got the impression that this is something that they didn't want to deal with themselves. So that's when they came up with the design to put in this perimeter curb. And right now they're actually pouring this perimeter curb around Reservoir 2. That large tower is off to the east. This is the west wall. They started the curb right here. We're working our way around here, but basically all we did was they poured this curb. We're attaching liner here using mechanical fastening, coming down across here and putting another hot air weld. Once again, this is another horizontal weld. It is at the top, but it's all locked in. So this material is still locked into the anchor trench. This is really just a cap to prevent any moisture from getting in that anchor trench. But this curb is a significant size curb. This serves several purposes. Safety, obviously people driving around this reservoir. We are in Colorado. There is not unheard of to get 3-foot snowstorms at this job site a couple times a year. So, you can be driving around this reservoir when there's snow. This curb should help prevent anybody from driving into the reservoir, or, snow plows, if they actually need to plow it, they can use this curb as a guide. So just preventing damage around here, around the perimeter as well. So this curb serves a lot of purposes, and I think it's going to make for a really nice final edge around the Castle Rock reservoirs compared to what we were facing over here at Chambers. All right, one of the other design details we put into this project was these safety ladders, and some of you on the call may be familiar with these, some may not be. But what these are is this is a textured sheet. And then this is embed. And what we typically normally use this product for is it comes in long sticks and it's got a T profile to it. And you can see in the photos that T profile, but what that is normally when they're pouring concrete, they actually push this into the surface of the concrete and vibrate it in to allow for us to come up and weld. So it's almost like a replacement for mechanical attachment. But what we learned over the years is since it's made out of the same plastic, we can weld these, we can flip these rungs over and weld them down, and they make for a nice ladder rung where, you know, you can imagine if you're out and walking around Castle Rock in February and you got 2 feet of snow and you slide into that reservoir and you're in your coveralls and your snow boots, you're gonna have a hard time getting out of that reservoir. You're gonna have to literally pull yourself up one of these ladders. So it's really critical that you have a good, strong rung to pull yourself out. And this is important. And they can also use these to access the water for, you know, doing water testing, sampling, anything like that. The funny thing we noticed at doing our walks around Chambers with the town of Castle Rock is there was feces at the top of each one of these ladders, and we couldn't figure out what the heck, why at the top of every ladder there was animal feces. And we've discovered that the raccoons are using this. They're walking down these ladders to get a drink of water and then walking their way back out. I guess that's okay. It's nice because we don't care, because this is a sacrificial piece of, you know, liner. So it's better that they're walking up and down this than keeping their claws and stuff off of this membrane. But it was kind of funny how the raccoons learned to use these ladders as much as, you know, as much as humans do. As you can see here, so here's Castle Rock, and the material's tan. We do the ladders in black, contrasting, versus the picture on the left is from another project we did out in eastern Colorado, where we actually used tan material because the liner was black. So you can see we do contrasting colors. That way they're very visible. You know, you can see this one way over here, you know, across the entire reservoir. You can see that nice ladder over there. So it's critical that they're a good visual. So in the event somebody is, you know, falls in, they can see those, whether that's from the water or, you know, from the top, they can see that to do the access. High strength reinforced material. I love this. I love these pictures. Like I said, these projects are a little near and dear to my heart. I have a little fun with these projects. But you can see here, we got a nice large tower. This is mid slope. So we're mechanically fastening the footer around this large tower. You can imagine how much stress that could put on that mechanical attachment. That reinforced material locks in very good. You can see how nice and flat this liner is around there. So when we're securing that, it's going in nice and we don't have wrinkles going into that. And you know, reinforced materials don't have a tremendous amount of like expansion or contraction. So we're not getting a tremendous amount of stress on these critical connections. You can imagine, you know, this is mid slope of, you know, 140-foot slope. You do not want a tremendous amount of stress on this mechanical fastening. And there's several structures in Castle Rock. This just happens to be the biggest one. The picture on the right is actually back to the Chambers Reservoir. And this is, I say that our liners are car crash proof. And the reason for that is because the Chambers Reservoir has a fairly, Chambers is the name of the road, that's why it's called Chambers Reservoir, but Chambers, the road Chambers runs parallel to the entire reservoir, and it's I believe it's 40 miles an hour right there. So it's just, you know, 2 lanes each direction. It's a fairly sizable road. Actually not a tremendous amount of traffic on that road just because where it sits, but it's access to C470, which is a large highway that perimeters around Denver. Sits right off here to the north, and so it's a big thoroughfare to get to the highway. And the reason I'm explaining that is because what happened here is, and I don't know who or what actually happened, but we speculate that they were either texting or distracted driving. There was, no proof that an animal was involved or another car. So what they did is they lost control of their car. They went up the curb. They went up, with kind of across a grassy, native vegetation area, through a 6-foot chain link fence, across the roadway and down onto the membrane. And crazy thing about this is, we get the call from Kevin and he's like, yeah, we had a car enter the pond. And I'm thinking, oh my, wait, somebody's in the bottom of the reservoir. You can imagine if he would have kept going. Actually, I think when he jumped the curb, he damaged his tires and the front wheels to where he actually, the front axles were broken and the front end of the car was almost laying on the membrane. So I think that saved him, because if he would have ended up in the water, it could have been very bad, right? We've since put in perimeter guardrails to prevent this from happening in the future, and they've beefed up some of that. But what you can see here is you can see the car sitting on there. Well, of course we get the call, and we're 15 minutes from here. So, my project manager and my ops manager jumped in the car and ran down there and watched them pull the car off. And they basically had to drag the car up and get it onto a tow truck up on the perimeter road and get it out of there. And we had no repairs to do. Everything was fine. We cleaned up a little bit of oil spots. We saw some scuffing. We actually, we did some patching over scuffing, but we actually tested them and nothing was leaking. But we reinforced some of the scuffing just to prevent future failure. So we did do some patching in this area, but none of it was because of leaks. So quite impressive, and I think it's a tribute to the reinforced material to show that kind of high strength. Also, the nice thing about LLDPE in general is it's a very inert plastic. It's very stable, very there's just not a lot that goes into it, so there's not any leachate, or there's not much additives that can come out of it. So it's really good for raw water storage, and you don't get any water quality issues. We use this a lot in like golf course and fishing ponds too, because it doesn't affect the fish. So it's good for raw water storage. All right, back to Castle Rock. What you're seeing in this picture is you're seeing the, I'm standing on the floor as I take this photo, and the reason I love this photo is because you can see here there's no wrinkle. And this is the slope creep that I was talking about, coming from the reinforced materials that have greater dimensional stability and less expansion contraction. So a lot of membranes are affected. You get a nice hot sunny day, get a lot of wrinkles, get a nice cool night, they shrink up. And what happens if you have that kind of a long slope all the way, 160-foot slope, you can get that expansion contraction before you have a big wrinkle down here. And I love the way this is laying in here. I mean, you get great intimate contact with the subgrade, just really, really good, lay flat, sitting against that subgrade. A lot of benefits to that. This next photo here, or these next photos you can see here, this is an unreinforced material. I like this one because you can see we're testing this weld here, and you got this giant wrinkle right here. And what's happening, and then same thing in this photo, is you got a sunny day, and this is all everywhere deals with temperature fluctuations. Colorado can be a little extreme because we have 300 days of sunshine, so we have a lot of sun, and we have high UV because obviously we're closer to the less atmosphere to filter out the sun. So we got high UV, we got high temperatures, but we got really cool nights. It's not like Phoenix where it's 90 degrees when you wake up on a July morning. Our July mornings are still 65 degrees. So you get these 35, 40 degree temperature swings every day. Today it's going to be probably 64 out, but we're going to be in the high 20s by tonight, or by tomorrow morning. So we get these high temperature fluctuations, and what happens is as it expands and contracts, you get this nice big toe wrinkle. Well, that can be a real problem if you're 160 foot of head pressure pushing down on a wrinkle like that. So the idea is you don't want these wrinkles in a toe. So that was one of the big reasons we chose the reinforced material and the tan material. Tan helps with that too. You know, black gets a lot hotter. So that tan is that's another advantage of going with a tan material. All right, here's the boat ramp. Kind of interesting. You know, some of the things we learned at Chambers was we put a ballast tube. We see these ballast tubes laying here, and we put the ballast tubes in this toe to keep that down. We actually put them on this side too here at Castle Rock. And what happened was when we were constructing Chambers, we had these tubes down the same, you know, the toe of this slope going down at an angle. Well, we had a snow event, so we got 6 inches of heavy snow. Well, it landed on the liner and there's 6 inches of snow. Well, then, of course, in typical fashion, 2 days later, it's 50 degrees. Now we've got 6 inches of snow sitting here with 50 degrees. Well, it starts to melt and big slabs of snow are sliding down, and they were just ripping the tubes and pushing them across the ramp. So we actually decided to come in here and weld a cap over, and I'll show you this in one of the last photos too, but we welded a cap over the top of those tubes, and that prevented them from moving. So that was another good thing, you know, like I said, kind of fun that Castle Rock got the benefits of us learning all these lessons on a nearby project. This right here is a, these were crazy. We didn't have anything to do with them, but they were precast concrete rolls, and they were on like a heavyweight grid, and then they cast concrete, almost like, looks like a sheep's foot, like when you're rolling the pond, you know, those you know, I don't know how to describe them, but basically it was precast concrete poured on top of a grid. And these rolls were, I think they were 6 foot diameter by 15 or 14 feet wide, 6 foot diameter. They were like 50 feet long, but they came on this truck, and these things, I mean, they must have weighed like, I don't know, like 14,000 pounds per roll. I think they could only get three or four of them on a truck. And so what they did is they took those, we put this wear pad and an additional protection of geotextile, then another wear pad. Then they put that concrete blanket or rolled concrete roadway down this, and then they actually put some gravel in there. And the reason this was important to Castle Rock is because they actually had a significant sized boat that they wanted to back down and be able to put out onto the reservoir. So it was really important for them to have this nice, good, stable roadway. They could back down in the winter. They didn't need to worry about sliding. They didn't need to worry about, you know, they didn't worry about danger, you know, like the safety aspect of losing off the side. They needed a good, stable road. And this is the design we came up with Wheeler to, you know, kind of keep that above the liner and not increase all this mechanical attachment by a poured roadway. And then, you know, if you pour a roadway and attach the liner to it, you know, the roadway can crack and you can get leakage out of it. So this was a way to guarantee a long-term roadway that was sealed underneath it. All right, so I'm going to talk about some of the advantages of the geotextile that we experience. And I think this applies to 95% of the projects. Let me refer, 90% of the pond projects that we do, any sort of water containment projects. You get this geotextile, it's a heavyweight fabric, and you put it under the membrane. It does several things. There's so many advantages. As you can see here in Castle Rock, you can see off here in the distance, you got this nice sand layer. So as you know, when you're digging a reservoir, you know, 60, 70 feet deep, you're going to get different sand, you know, different soil layers, and we had a sand pocket. Why this is significant is that geotextile is going to help lock that in long term. So, you know, we face this a lot in the West, is you get the sandy subgrades. Well, you just put the liner over the top of the sandy subgrade, and then you get heavy winds. Now you got wind uplift if you don't have good venting and good ballast. You get wind uplift, and then you get these wave actions that just beats on the slope, because you got the wind coming across, lifting the liner up, then you got waves hitting that membrane, and it actually loosens the soil layer, and you'll begin to see sloughing underneath the membrane. Very common issue that we have out west, especially in like western Nebraska, Kansas, eastern Colorado, Wyoming. We get these sandy layers. And so this geotextile actually stays against the subgrade and takes that wave action beating. It also allows for gas to migrate up the slope and to the vent, the detail you're seeing here. Geotextile also protects, so you get protection of the subgrade, any imperfection of subgrade, any rocks that get put in here, this textile will protect from that. You get the venting benefit. You also get a nice clean surface. So you can imagine working on a nice clean geotextile when you're running your welds up and down these slopes is much better than running through the dusty dirt, the mud, anything wet or anything like that. We did prefabricate these panels. So you can see that, you can see this nice little edge here and then another one. So these are all prefabricated panels. So we made them in a very large panel, prefabricated, just to reduce the installation time. And you can see the one prefabricated panel right here of the tan material. I'm going to talk about a little bit of the modular construction with this slide. We had just pulled this panel out. We're letting it sit in the sun for a minute to heat up, and then when we go to, right before we go to pull in the next panel, we'll snap all these wrinkles out, get it laying nice and flat, just like these textile panels are. And you can see here, I put a note in here, and this was about 6 weeks ago. We had an 18-man crew out there, and we actually got 380,000 square foot of geosynthetics in one day. I want to give a big shout out to Nick, because that was a very impressive day to manage that amount of people and that amount of production. All right, you can see here, this is just some of the statistics on the job. 2.7 million square feet of geosynthetics, half and half of textile and membrane. You got 1,105 linear feet of ballast tubes. So we put ballast tubes around the entire toe and then up and down those ramps. Plus you got 10,200 linear feet of mechanical attachment onto that curve around the perimeter that we discussed. Couple challenges that we faced. So obviously weather, you can see here, this is a nice September day, got a tremendous amount of rain, completely filled this anchor trench, and this roadway got a little slick and snotty, I like to say, and was a risk because now you've got a pond on this side and you've got a 200-foot slope down off the other side. So you want to be real careful accessing this. Once again, we were, finishing phase one of reservoir 2 last fall, and you can see how much snow we got and how difficult this was to deal with. So weather is always a challenge. We're constantly dealing with that. The structures, like I talked about earlier, you can see here where this is us fastening. There's the bridge above to this large structure here. The reinforcing, again, talked about that helps there. You can see here the geotextile on the bottom, and I like this photo because in the photo you can actually see the different panels. They get a little bit different hue as you put them in because these ones might have been installed. These two were probably installed that day. These ones were installed a couple days before, so they got a little bit of moisture on them, and they get a little bit of blowing soil, blowing dirt on them. So they got a little bit different color to them as you move across. The different layers get the different days. You can almost see them from the just from the little bit of soil getting put on there. Yeah, this is another thing we learned at dealing with the Chambers Reservoir. So here's a mechanical fastening down to this structure, and then they're going to actually secure a metal depth gauge to this. They like this design because they had to put this in for the valve construction here anyway. So we went ahead and secured the liner with mechanical fastening so they could mount their depth gauge to this. And this here was an interesting detail. So what you're looking at here is you're looking at a black membrane, same membrane, just black. And right here at the top, we actually sewed in our factory in Madison. We actually sewed in a Velcro strip on both sides. So they can actually open this up like a, just you can open this up and lay their pipes for, aerators and stuff like that. They had some pipes they wanted to lay in here, but the concern was if we secure them to the liner and then, something happens to the, the bubbler or something down here in the bottom and they have to remove it, they don't want to have to drain the entire reservoir to remove that. So we came up with this design, and we actually came up with it through the, from our ag division where we do tarps over the top of silage piles out in the farmlands. They use this detail to secure the different panels together. So kind of a fun detail, kind of a different, unique way of doing it. And my last slide here, this is just showing that that I talked about earlier. Here is the ballast tubes that I referred to. These went up and down both sides of the concrete ramp. This kind of secured the rock and stuff from sliding down the slope. And then on this side, it kept the, from getting that toe to uplift. And then you can see in this picture to the right, you can see the cap that we put on it. And we did this at both chambers and at Castle Rock. So this cap was really, ended up being a really nice detail in the end. All right. I think I'm to questions now. So who knows? If anybody have any questions, please chime in. I'd love to answer them or hear what you have to say.
Thank you, Alex and Pat, for that great presentation. So we did have two questions that have come in. The first one is, are these above ground reservoirs?
Yeah, so that's kind of, no, not, yes, they are exposed reservoirs. They are, they're there's no top on them eventually, but they are, Reservoir 1 was pretty much dug down in. Reservoir 2 was kind of built against the slope. So on this side, it was against native soil. On the far side, it was actually a complete embankment and had to go under a jurisdictional dam. So, we had to go through dam safety to build that. And yeah.
And Pat, as Pat was saying earlier too about chambers, that was 160-foot long slopes, basically, or the panels were. So that was dug underground basically, but yeah, it's still, kind of above ground too, though.
The second question is there any concern on wave action delaminating the liner?
No. We've been installing this material for I don't know, 20 plus years. Coming from the installation side, I run the installation, so I get all the calls for repairs or, somebody cut holes in a liner from a lawnmower or whatever the reason, they need to add a pipe later, or so I get back onto sites multiple times a year, and I've never seen any delamming, especially with the way we build the LLDPE. So no, I don't have any concerns of that. Both of these products come with a 20-year warranty, material warranty, and we always expect them to far exceed that warranty.
I think attendees really want to know about this liner material. So the other question is, how thick was the liner material?
Yeah, maybe I didn't note that. Yeah, So we refer to that as an N45. It is 45 mil thick. Both reservoirs at Castle Rock were the 45 mils, and same as Chambers. So they were all three reservoirs mentioned in the presentation were 45 mil tan LLDPE.
Let's see. Okay, there's another question. It's not about liners. Were there any sliding stability concerns between the GT and GM?
No, yeah, no, like I'm assuming you're talking about interface friction. You know, I mean, interface friction is a huge concern. Obviously, you know, we do a lot of landfill construction as well. But when you're doing a reservoir construction, you know, you're basically always filling from the bottom. It's water, and it's, you know, it's constantly pushing against the slope from the bottom up, very consistent. Where you get into really big concerns with slipping or sliding is in the construction of like landfills, where you're starting to load that slope with solids or soil or trash, and now you got a downward force that's pushing on that liner. When you're dealing with water, you're almost, you know, just pushing it against the slope. So interface friction testing was done. You know, W.W. Wheeler did their due diligence on making sure those interface you know, frictions met their safety factor, but no real concern with that, and we've never really seen any issue with that at either reservoir.
Well, this is the last question about liner. Does the groundwater come up and result to uplifting of the liner? I feel like you may have touched on that in that question I just asked.
Yeah, no, like I didn't really get into that, but you know, groundwater is a huge concern. I actually just did a webinar on ballasting liner systems last week, and that's one of the main problems, controlling groundwater. In this case, we did not have any issues with groundwater. Ironically, not to get too into details on the Chamber Reservoir, but the Chamber Reservoir was actually 20 feet deeper at the time that it was constructed originally, and it was not lined. And they actually did have a lot of groundwater issues, and they had some extreme slope failures due to the groundwater. And part of that solution was to bring up the floor of the reservoir. They actually reduced the capacity and brought the floor up. And so to get out of that groundwater, and then they actually did a perimeter underdrain system to prevent any uplifting. And in the Chambers, in the case of the Chambers Reservoir, we actually, in one of the photos, you could see these berms that we built. And the reason those berms are in place is because as they drain the reservoir, they want, you know, obviously if you've got 70 feet of head pressure pushing down on that membrane, you don't have a huge amount of concern of uplift. But if the reservoir goes dry, obviously you reduce your weight going down. So we put those perimeter or those berms across there to trap water at each elevation down down the long narrow reservoir. And that water was designed to keep that ballast, that weight of the water on that floor, to reduce any uplift from groundwater. But part of that design was an underdrain system and continued ballast, and then obviously building that up to get out of the real groundwater issue. Several ways to design around that, and both engineers did a great job of doing that.
I thoroughly enjoyed this presentation, as I'm sure all the attendees did. We do have time for one more question, and I think we really want to know, did either of you actually see any of the raccoons going up and down these ladders, that you like actually witnessed them?
It was funny because, not to get too gross, but the feces was quite large, and at first I was like, "What is that? Is this a bear?" And I mean, it was large pile every time. And the funny thing was, is we had I can't remember his name, I apologize, but he was a younger guy, and he chimed in, he goes, that's definitely raccoon, you can, and he knew, he knew, and he goes, that's definitely raccoons. And I was like, okay, well, I know, but I did not witness it, but ironically, we did see their footprints around the perimeter, because they would get on the mud and then they would step on the liner, so you could see little footprints, especially at the top of the ladder, because it was black. So you get that muddy footprint. You could see their little paws. So it did become obvious as we were walking it that it was raccoons. But no, I didn't get the chance to witness it. I probably have to go out there at night to do that.
Wow, well, glad you had some little friends.
Yeah, it was quite entertaining, and it was quite fun discussion at the walkthrough.
Right. Well, again, thank you guys for that presentation, and thank you, Viaflex, for sponsoring this webinar. To the audience, please send in any other questions you may have, and we'll pass them along to our speakers for an answer. We are continuing to add webinars to our calendar, so make sure you check out all of our upcoming webinars and events by visiting textiles.org/events. As you close out today's webinar, you will find a very brief survey that will appear when you exit the webinar. We really appreciate if you took a few moments to complete it. And with that being said, Alex and Pat, do you have any closing words?
No, thank you for taking the time. I hope it was beneficial and everybody learned something. So hopefully that was helpful. Yeah. Feel free to reach out. There's our contact information. That's my cell phone. That's Alex's cell phone. There's our emails. So if you have any questions at all, we'd be happy to help you in any way we can.
Absolutely.
All right. Thank you all for attending, and have a great day.
Thank you.
Thanks.